Bill Evans couldn't make it, so you're getting cheap Bill Evans. Me, Dave Cullen, how you doing? Anyway, last minute change there. So, the future of medical technology and our healthcare. I'm joined for this panel by Karl Martin, founder and CTO of NIMI, and Arjun Bansal, co-founder of Nirvana Systems. Gentlemen, welcome to you both.
Thank you.
Before we get started, if you guys could give like a general overview of your experience and your background first and what you're currently working on. Arjun, if we start with yourself.
Sure. So my background is in computational neuroscience and brain-machine interfaces as well. And right now, I'm one of the founders of Nirvana Systems, which is a deep learning cloud platform.
Mm-hmm.
So some of the speakers have already talked about this field of deep learning that's kind of exploded in the last couple of years. And it's been applied to a whole bunch of different areas. And we're building a cloud platform that makes it really easy to apply these algorithms at scale and also apply them in a really fast way. So, because it takes a really long time to train these algorithms.
Okay. Carl?
Well, so my background is in biometric security and cryptography. So, I mean, the biometric side is really about taking signals from the body and using that for identity authentication, but the foundation there is really about signal processing. I mean, we're talking about very noisy, small signals, but can potentially derive a lot of insights from them. And so that's a lot of the work that I've done. And so I'm co-founder, CTO of NIMI, and we take that kind of technology and we've made a wearable authenticator. But the signal that we're using is actually the cardiac rhythm. And we authenticate identity from one's cardiac signals, which is unique for everyone. So it's this sort of chain of things going from extracting signals from the body, taking those tiny signals, machine learning, and creating a unique template for each person, recognizing them, and then tying that to a cryptographic system that can then be used for accessing things like unlocking computers, doors, and whatnot.
Passwordless login through your heartbeat.
Future.
Fantastic.
Yes.
So I'm going to cheekily, the first question I'm going to throw at you is, I'm going to cheekily use the topic of this panel, which is with biometric big data and machine learning, are we on the cusp of a revolution in healthcare? Arjun, what do you reckon?
I believe so, yeah. So I think the computational power that is becoming available now is truly going to revolutionize healthcare on the analytics side for sure. And thanks to devices like NIMI and others, I think, and also from just smartphones, we have the capacity to collect so much more data and sort of plugging that into the cloud, being able to analyze it, give back some insights in real time to the user. So there's a lot of potential. I mean, there are some sort of roadblocks, I think, but over the course of time, I think we are going to be able to do some really good things.
Carl?
Yeah, so I can break it up into different pieces, but if you look at the sensor side right now, it's amazing what anybody can do with a sort of small engineering team and just pick up off-the-shelf sensing technology. It may not necessarily be FDA approved or the most high fidelity signal, but it's something that can be done now, low power, put in a wearable, put into a mobile device, and that has just enabled just innovation where startups are saying, hey, what can I do with this? And I think it's just this fertile ground. And I mean, for us, we didn't start off making hardware. When we started off in 2011, we were just focused on the algorithms of processing the biosignals. And then in 2013, there was, we came up with this epiphany that we could put it into a wearable, but one of the pieces of technology was off-the-shelf sensor. A major company, Texas Instruments, said, well, we're going to sell this biosensor chip. It's going to cost $1, in volume, even less in the future. Low power, can run off of a battery. It's like such a small thing on a sheet of components, but now it's possible anybody can buy that and create a device, and that wasn't possible a couple of years earlier. So I think those kind of advances, they're kind of behind the scenes, but they're enabling this fertile ground that can feed into greater insights for medical care.
Sure, absolutely. And on the subject of that, wearables are becoming ubiquitous, obviously at the present time, still very much companion products to smartphones. But from a consumer standpoint, they remain focused on fitness tracking, They've got every sensor under the sun for galvanic skin response, to heart rate monitors, to tracking your steps, your sleep, what have you. But there is, it seems now, an evolution towards making them fully fledged healthcare products. And there is a big subtle difference there, isn't there, Karl?
Yeah, so I think the initial introduction of wearables into the consumer space was in some ways a little bit of false hope initially because, well, first of all, most things were just counting steps, right? And the insights are somewhat limited in that. But furthermore, even if you add heart rate monitoring and other bio data there, initially, the information has to be useful, has to be insightful, has to inspire behavior change and action. And I think that's what's been missing. There was this initial kind of like, it's new, we can make it, it's wearable, you know, battery lasts 7 days, consumers will pick it up and give it a shot. But, you know, the sort of the dirty secret in the wearables industry is that, you know, most people don't wear them after 30, 60 days. But that's just today, or I would say with the last generation. Where I think this is going now is as you leverage greater computing power with smartwatches or you know, piping data into the cloud, now you can get more useful insights leveraging machine learning so you can get personalized insights that can inspire behavior change and improve one's health outcomes rather than just a piece of data flashing in your face.
Mm-hmm, absolutely. Arjun, in my research for this panel, I discovered an Israeli startup called Unispectral Technologies. They've developed this optical lens and image processing software that's supposed to turn your smartphone into a hyperspectral sensor, and they can break down the chemical components of any liquid just by looking at it as opposed to having to take a physical sample. So smartphones already have a myriad of different functions, we know, but how far are we away from seeing them become synonymous with having the Star Trek-style medical tricorder functionality as well?
Yeah, I think that's a fascinating question. I mean, a lot of us who have joined this kind of field have been, you know, we got into it partly because of sci-fi and sort of making those dreams become reality. And it really does feel like we're on the cusp of getting there now and at this moment. With regards to the tricorder, I think we're making tremendous strides on the analytics and the algorithm side now in terms of taking whatever sensor data we can get and making inference off of it. And we're starting to do that for some of these signals like heart rate, and I think with these chemicals sensors we might be able to do more. But we might still be a little bit further out from things like doing like a handheld MRI or something like that. So, so I think we're on the right track, but I really look forward to more advances on the sensor side as well.
Yeah, still some time to go. Karl, the term self-diagnosis carries with it some very bad connotations of people going to WebMD with the minorest of things and blowing it out of proportion and think they're dying. But that's effectively what we're going to be giving the patient/user now. They're going to give them all this data and they're going to be able to analyze it themselves and hopefully make well-informed decisions about their health. Talk about how you see the patient-doctor dynamic changing completely as a consequence of having this data so readily available.
Yeah, so first of all, I think we're all usually guilty of whenever we have a symptom or something, we have this wealth of information available to us, and we try and be that go-between to do self-diagnosis, and we know where that leads. It just usually stress and not actually useful outcomes. But I think what's filling that gap is the potential to get real-time data and then connect that to whether it be actual professionals or it be machine learning, AI, that provides useful insights from that. Because traditionally, to tap into, there were two separate worlds. You have your home consumer world, and then you have the world of going to doctors, going to labs. And the two are separate, and the problem with when you go to a doctor in a lab, it's just a pinpoint in time of what's going on with you. And somehow I always have high blood pressure when my blood pressure is being measured at the doctor, and yet if I go and do it myself, I get a different result, with the machine at the pharmacy. And the reason, it's kind of like the Heisenberg uncertainty principle. It says that when you measure something, you affect it. And by limiting that measurement to when I go to a doctor's office or a lab, I'm not getting useful insights. I have this rest of my life that I go about every day, which is my normal life. And so I think this is the gap that is being filled by putting sensors on the body, getting real-time information, and then connecting that to where insights could be derived from that. And I kind of see this chain of signals, insight, action, right? And signals we now are democratizing by virtue of wearables that anybody can have. And the insight used to be segregated into this, the medical profession. If we can connect those, then we can get useful action from that and sort of complete that chain and actually, leverage all of this wealth of information we can gather.
So we're totally removing any bias from the testing process.
I mean, as a scientist's background, I would say it's impossible to completely remove bias, but I think by having a broader wealth of information, you can compensate with volume, with appropriate analysis of that data. And, I think traditionally doctors have liked to control everything, but if you compensate by much more data, just a breadth of data that is 24 hours a day rather than that point in time when you're in a doctor's office, I think everybody can appreciate the power of that.
Absolutely. Arjun, deep learning is often cited as playing a pivotal role in the future of healthcare. Much of this is over my head, so I'm relying on you to break it down for myself and anybody else who doesn't know about it. Deep learning. Can you talk us through that a little bit?
Yeah, sure. So deep learning is a technology based on artificial neural networks. It's 2-3+ decades old. But recently, thanks to larger data sets, better computing power, companies like Google and Facebook have been able to use it for things like face recognition, image recognition, speech, natural language processing, analyzing time series signals. What we're doing at Nirvana, for example, is taking those algorithms and these approaches that people have taken to solve these problems in the consumer domain and bringing them to other domains, and healthcare is one big domain.
Absolutely. There's going to be a number of breakthroughs in high-performance computing that's going to drive down the cost of gene sequencing, for example. Can you talk a little bit about the benefits of gene sequencing for the average patient user out there?
Yeah, so I think applying these time series algorithms to analyzing the gene sequence data is something that's just being started. Like, we've just scratched the surface of these algorithms, and there's tremendous potential. Like the same algorithms that people use to use things like Siri or Google Voice, and these are getting really good if you've used them recently. The same underlying algorithms can actually be applied on any sequence, and the genome is one such sequence. So I think this is going to revolutionize how people discover drugs, and all kinds of biomedical decisions could be based on people sequencing, and especially as the cost goes down as well of the sequencing.
Okay, so this could literally mean that people will be able to predict the diseases or ailments they're going to suffer in later life.
I think we have a much better understanding, at least to the extent that those diseases are caused by the genome, because there's always the nurture component to these diseases as well.
But that would mean that you would be able to literally develop targeted treatment specific to a person, as opposed to a catch-all, which is what we have at the moment, where there's side effects and everything else. So you could totally reduce those.
For sure. I think there'll be a much more personalized component in medicine thanks to these algorithms.
Mm-hmm.
I would actually add to that. So there's actually a company, an early stage company, Renomics, based in San Francisco, where they're taking some of these early stage approaches to predictive medicine. The problem with predictions is it requires data, right? You actually require a lot of data, but in the world of genetics, there's a lot of things that occur that are actually individually quite rare. So different genetic variants, which don't occur in the population very often, but result in a certain outcome. It's very hard to make predictions because you don't have data for that. So you can actually compensate using high-performance computing to actually do large amounts of sequence data and map out outcomes. So you don't actually need to collect you don't actually need many, many samples from the population. So this is where computing can actually compensate where there's limited population data. So it's this marriage of data plus computing, and that is opening up a lot of possibilities.
Absolutely. The other thing that it's going to lead to, I suppose, in a revolutionary change is in the topic of insurance. So it's a little bit left of field, but it's something we're perhaps all going to have to think about, and maybe it'll be 20, 30, 40 years before this is going to come to pass, but it may come a time when a health insurance provider will specify that you must have your genome sequenced prior, so that they'll know pretty much. I mean, as we know, health insurance providers always want to know as much about you, so they can tailor an extra expensive package to you. If they're going to know, okay, you're predisposed to cancer, stroke, Parkinson, MS, whatever it's going to be in the future, presumably that's going to change the entire health insurance landscape. Who wants to take that one?
Yeah, I can start. So I think some of that will have to be regulated by the government to ensure that there's no discrimination. And I think in the Affordable Health Care Act in the US, there are some rules about not discriminating based on information from the genome. But I think further down, there could be some parallels, for example, with self-driving cars. When they become really good, insurance companies will make the premiums for humans driving cars really high. And so similarly, I think there could be potential for, like, if you're going to have children and you'll have to get them sequenced before the insurance is sort of willing to allow that. That's sort of a Gattaca-like future that might be enabled by that.
Slightly Orwellian, isn't it?
Yeah, no, I must say that this is a huge pet peeve of mine, because insurance companies want to manage their risk better and better, but you get to the point of saying, well, why do I have insurance? Because if they can so accurately take that data and predict outcomes, then I can do that myself, and I can, they're just going to charge me the same plus a premium to manage the outcomes of that, then I might as well just pay for it directly myself. So I think there's this element of what is life insurance, and we might actually see, or I should say, sorry, insurance, not life insurance, but we may actually see a major disruption in insurance with greater data. It really changes the nature of their business, where it used to be much more broader risk models. Now you can have much more personal management of outcomes, and I would say insurance might change or even go away as we currently understand it.
That would be nice, wouldn't it?
Yeah.
Absolutely. It's a huge subject, the future of technology in medicine, and unfortunately we've only just scratched the surface. We're out of time, and we didn't even get to talk about all the robots that are going to take over our brains in the future. There you are. Thank you so much for joining us, ladies and gentlemen. Karl Martin, founder of CTO NIMI, and Arjun Bansal, co-founder of Nirvana Systems. Thank you.
Thanks.